Indefinite integral learning outcome. From here, what we will get at the end of this video, we able to solve antiderivative, and then second, we are able to differentiate the properties of indefinite integral. So let me introduce here. Okay, now introduction. Indefinite integral, or sometimes called antiderivative of a function fx. So here the function of fx. So the integral, and so indefinite integral, we know that the fx plus c. A function, the derivative of which is fx. So the function derivative, because the derivative of a constant 0, indefinite integral is not unique. Okay, now the set of all antiderivative of a function fx is the indefinite integral of fx with respect to x, and denoted by integral fx dx. Generally known of antiderivative. So a function f is an antiderivative of the f on an interval I. Then the most general antiderivative of an interval is fx plus c. So c is any real constant. The process of finding the infinite integral is also called integration or integrating fx. Number 2, a function f is an antiderivative of integrate fx dx equal to fx plus c. Unlike the definite integral, the indefinite integral is a function. We know that here is a function. Okay, like some example here. Okay, so d over dx x 2. So when we derive this, we get 2x, right? And then dx x2 plus 1 also will get 2x, right? So we can conclude that indefinite integral is what is 2x the derivative of. We know that x2 or x2 plus 1 is equal that x2 plus c. We put this integral to x dx, we will get x2 plus c. Definite integral versus indefinite integral. The definite integral have their limits. Indefinite integral did not have any limit here. We know before this definite integral, when we integrate x2, so here solve that like x2 plus 1 over 2 plus 1. So we get x3 over 3. So, because they have limits here, we just change into this and to this, and then we get okay here. For indefinite integral, we do not have any limits. So when we integrate x2 dx, get only x3 over 3 plus c. Time when we do anything, we have a common mistake that we need encounter. So dropping the dx at the end of integral, the integral fx dx not equal to integral of fx, because this is a symbol of derivative. So next, forgetting the plus c during the solution process. When we integrate x2 dx, it's not same as x3. Even though this is a correct, we need some exercise.
Solar a well, own me, crossies, Coco Chanel, palm trees, calm breeze, living in a dollhouse. I don't need a can, I can watch it walk out solo, but I got many I can thank. You could see it in my eyes, like every time I blink.
Hello everybody, so today we'll be learning about definite integrals. So we'll be learning about what is definite integrals and their properties, but we'll be more focusing on how to evaluate definite integrals. So for learning outcome, at the end of this video, we'll be able to define definite integrals. We'll be also be able to understand in the deeper level what is the different properties of definite integrals. And lastly, we'll be also able to solve problems related to area under the graph. Definite integrals. So first and foremost, we must understand that definite integrals has an start value and an end value, which means it has an interval. So that's why all definite integrals has upper limit and a lower limit. And for us to evaluate a definite integral, we must find the antiderivative of f of x. After we find the antiderivative of f of x, we can write it as capital letter F, and we sub in the upper limit, then we minus the lower limit, then we can find the value of definite integral. This is the general formula, which is x to the power of n plus 1 divided by n plus 1 plus constant c. So in definite integrals, we don't really need to write the constant c. I can show you why. So let's see an example. So for this question, the function 2x plus 1, if you want to integrate 2x plus 1, x to the power of 1 to the power of 1 plus 1 over 2 plus x plus c. And when we sub in the upper limit and the lower limit, we can find the value, which is 4. We can see that the constant c doesn't really play much role here. Constant c will cancel out each other. So that's why we don't really need to write the constant c in definite integrals. Property of definite integral. So there are 6 properties of definite integrals. First one is constant factor can be moved across the integral sign, which means the function we can factorize, we can move it to the front of the integral sign. Let's see this example. If you factorize it and we find the constant, 3 is the constant, we can move it in the front. The second, definite integral of the sum of two functions is equal to the sum of integral of this function. So if we have two functions f of x and g of x, but we have the same interval b and a, let me show you an example. This is a question, then we can write it in this expression. The third, which is reversing the limit of integration, changes the sign of the definite integral. It became negative because the direction of the integration has been changed. Suppose from a to b, it will become integrate from b to a. So that's why there's a negative. So next, suppose that a point c belongs to the interval ab, then the definite integral of a function f of x over the interval ab is equal to the sum of integral over the interval ac and cb. Let me sketch a graph. Okay. Y-axis, x-axis. Okay, let's say this is our function fx, f of x. This is our a, this is our b. The property says that c is in the middle of the interval, so we can say that c is here. Sum of integral of a and c plus c and b is equals to a and b. If the upper and lower limit of a definite integrals are the same, the integrals is 0. If the upper limit is equals to 3 and the lower limit is equals to 3, because it's the same, we know that it is a straight line. If it's a straight line, there is no area, so that's why the integral is 0. Last property, the integral adds the area above but subtract the area below to find the net value. For this type of question, usually function will be like this. The function will be like this. For this property, it basically means we find the one minus the area below the x-axis to find the net value. So now we'll be doing some exercises. There are 2 questions. Just quickly pause this video and see if you can get it right. Okay, now I'm going to reveal the answers. I think most of you will be confused at the part with 3 over x power 3, where when denominator, we bring it to the numerator, the power 3 will become negative. The other one, we just sub in the upper limit and the lower limit and we can get the value. And for the second question, we know that square root of x is the power of 1 over 2. But if we bring it from denominator to the numerator, it will become negative. So negative 1 over 2 plus 1 will become 1 over 2. And just sub in the value and we can get the answer. So this is the last part. So I'm going to show you how to solve this type of question, which is the area under the graph. When x is equals to 0, y equals to 3. When y is equals to 0, x squared minus 2x minus 3 equals to 0. So factorize this, x plus 1 x minus 3 equals to 0, x equals to -1, x equals to 3. From the question, we know that it is negative x squared. Usually graph will be like this or this. Since it is negative, so we know it is this one. So this is our graph. This is the area that we want to find. So we just integrate everything. So 3 to -1, negative x squared plus 2x plus 3 dx, negative x cubed over 3 plus square plus 3x. 3 -1, 3 negative cube over 3 plus 3 square plus 3 minus -1 cube over 3 plus -1 plus 3 -1. The answer will be 2 over 3. So that's the answer. Thank you for watching, guys. Hope everyone has a nice day.